So here we're going to try out a couple more limits at infinity and see what we come up with. For our first example here, we have the limit as x approaches infinity of the square root of x squared plus 8x minus x. I realize that we can't actually use the direct substitution property here because we can't plug in infinity, but I do want to point out that the first radical here, as x goes to infinity, is going to become infinite as well. And this x, as x goes to infinity, will become infinity as well. So this is an indeterminate form of the form infinity minus infinity. Now, back in a previous section, when it came to radicals being added or subtracted, I would say multiply top and bottom of that fraction by the appropriate conjugate. But this isn't a fraction. Or is it? Sorry, gotta entertain myself. So with that in mind, I am going to do exactly what I just said I'm going to do, which is multiply top and bottom of the big fraction by the conjugate of the numerator. So same radical, same x, I'm just going to put a plus sign in between them. The idea is, up in that numerator, if you have a minus b and you're multiplying by a plus b, you're going to wind up with a squared minus b squared. So let's write out what that's going to look like. So it'll be the first thing squared minus the second thing squared. Your denominator is fine the way it is. Now, continuing to simplify the numerator, we'll allow that square to cancel out the radical that's in the numerator. We'll wind up with x squared plus 8x minus x squared all over the square root of x squared plus 8x plus x. Continuing to simplify the numerator, we can cancel out the x squared terms that are there. We'll get the limit as x approaches infinity of, numerator is now simply going to be 8x. Your denominator stays the same as the square root of x squared plus 8x plus x. Now with that in mind, if I were to attempt to use the so-called direct substitution property at this point, even though we can't really plug in infinity, we now have a fraction where the numerator is approaching infinity, and your denominator would be infinity plus infinity. Well, that takes the form infinity divided by infinity. We can proceed here the same way that we proceeded with the other examples, which is identify the largest power of x in the numerator and denominator and divide both sides by, or divide both numerator and denominator by it. Also, I misspoke. We're just looking for the largest power in the denominator. So that would be the x squared that we see that is underneath the radical. So what I'm going to do is divide top and bottom of the big fraction by x. So what happens with several of the terms is going to be fairly straightforward. This 8x, when we divide by x, will become simply 8. This x that we have here, when we multiply by 1 over x, will become 1. But to force this thing underneath the radical, I'm going to need to use the same trick as what we did in that previous video and refer to it as the square root of x squared. Keeping in mind that the square root of x squared is equal to x, provided that x is greater than 0. Now, given that x is going to positive infinity, we don't need to worry about that. So, bringing the x squared inside the radical that's in the denominator of this nice big expression here. Numerator's still 8, we'll still see a plus 1 over here, and now our radical will be x squared plus 8x all over x squared. As we did in the previous video, we can distribute this x squared to both of the terms that we see in the numerator. And when we do so, we'll get x squared divided by x squared. That is 1. When we do 8x divided by x squared, that reduces to become 8 over x. At this point, we can now allow x to go to infinity, which is not really the direct substitution property, but it's, it's close enough. Numerator is still 8. Denominator is now the square root of 1 plus 8 over x is going to go to 0 as x goes to infinity. Therefore, we're going to have the square root of 1 plus 0 plus 1. Simplifying one step at a time, we get 8 divided by 2, which gives us a final answer of 4. So we just started with an expression that would have been infinity minus infinity, and we got a final answer of 4. How about that? Weirder things have happened. I do want to try out one more example that is going to use a trick similar to the one that you see here, but used in an entirely different fashion. For this problem, we're going to take the limit as x goes to negative infinity of 3 minus 4x, don't worry about what that is, this is 3 minus 4x, all over the square root of 9x squared plus 6x. Now, if we were to attempt the direct substitution property, which obviously we can't really do, if x goes to negative infinity, we're multiplying by an additional negative, that would become positive infinity, and your denominator would be, let's see, that'd be, well, we'll approximate that as some sort of infinity. So with that in mind, we're going to do the same trick as what we did on the previous problem. Identify the largest power of x that's in the denominator, which is the x squared that's underneath the radical. We'll go ahead and call it 1 over x. Now, here's where something kind of tricky is going to take place. In the numerator, I'm going to distribute this and have absolutely no difficulty whatsoever. In the denominator, though, I need to force this x under the radical. And so I want to give everybody a quick reminder of what the square root of x squared is actually equal to. It's actually equal to the absolute value of x, which means that it's going to be x as long as x is greater than 0, but it's going to be negative x provided that x is less than 0. And it's safe to assume in this problem that x is going to be less than 0 due to the fact that it is approaching negative infinity and not positive infinity. Therefore, x is going to be equal to the negative square root of x squared, provided that x is less than 0. That causes an additional negative to pop up as we make that substitution. Now, with that in mind, that negative can just chill out in front of the radical for the time being, and this will become 9x squared plus 6x, and the whole thing will now be divided by x squared. Your numerator stays the same. Then we can distribute the x squared that we introduced to the radical to both of the terms that are in the numerator of that denominator. So 3 over x minus 4 stays the same, and we have a negative square root of 9x squared divided by x squared will reduce to 9, and 6x divided by x squared will reduce, but not completely, 6 over x. At this point, we can now allow x to go to negative infinity, and anything with a number over x is going to go to 0. So your numerator will be at 0 minus 4. Your denominator will be the negative square root of 9 plus 0. When all is said and done and simplified and whatnot, you have yourself 4/3. There's one more example, but I think we'll save it for the next video.